In this video we are going to start studying object-oriented programming with a program called Rectangles.java. So in this program we have a very simple class named Rectangle, and we are going to create objects of that class, and we are going to study what constructors are, and then we will also discuss how objects and objects references are allocated memory. My name is Kari Laitinen, and let's go to see the program then. So you will find the program when you go to naturalprogramming.com and you click this Java icon, and then you enter this page, and the program can be found on the line that says very simple classes. There is the Rectangles.java. So I have already downloaded the program, and if I run it, well, I can first compile it like this, and when I run it, it prints very simple rectangles to the screen. So the first rectangle is made of Z characters, and the second rectangle is made of X characters. And the source code of the program looks like this. So in this program we have now this class named rectangle. It starts from here, and then the rectangle class ends to this closing brace, and then we have another class named rectangles, and inside these rectangles we have just the main method of the program. So now we have two classes in a single file, and we could first take a look at this main method. So in the main method I create then objects of this rectangle. So I write rectangle and first rectangle, and then I assign a new rectangle, and there is the semicolon at the end. So here with this expression I create a rectangle object, and then I can do some operations with a rectangle object, so that I first call a method named initializeRectangle. So with this name I can refer to the created rectangle object, and then with a dot operator I can call a method for the object, and here I first call the method initializeRectangle, and I give it the parameters or arguments 7 and 4 and Z, and this is now a character parameter. And then I call the method printRectangle, and this then produces this output to the screen, so that I have a rectangle filled with Z characters, and it has 1, 2, 3, 4, 5, 6, 7. It is 7 characters wide and 4 lines, or the height of the rectangle is 4 lines. And then in the same way I create another rectangle, and I refer to this rectangle with the name second rectangle, and I create it like this, and then I initialize it with 12, 3 and X, and this means that I create a rectangle that contains letters X, and it is 12 character positions wide and 3 lines. The height is 3 lines when I print it. So this is quite a simple program, and it is quite useless program as usual. So just a textbook program, and but this shows the basic idea what an object and what a class is. So when I have created the class, I can refer. So now it's important to notice that there is this rectangle is the name of the class, and when I create an object, I use that name to create the object. And then I always, when I have an object, I have to have some name for it, and then I can call methods for the object with a dot operator, like this. So let's take a look at this rectangle class then, and inside the rectangle class I have now defined variables, or these are now actually called data members. So these are often called data members. Or they are called also data fields. Sometimes they are called attributes as well. But so now I have 3 data members in this inside the class, and then I have 2 methods. So let's write it here. So this class, it has now 3 data members or data fields, and it has 2 methods. The first method is initialize rectangle, and the second method is print rectangle. And what it means when I specify a rectangle object, it means that the object contains all these data members or data fields. So they are contained in each rectangle object. And then I can refer to these data members with these methods. And then, so when I, for instance, when I call this initialize rectangle method and I specify these parameters or arguments, so they are copied to these. So they are copied to these variables here. So they are like method parameters, and then here they are copied to the data members. So each of these parameters are copied to the corresponding data field of the class. So this method initialize rectangle, it just copies all the 3 values to the data fields or data members. And then this other method, it prints the rectangle. So what happens here is that it now uses 2 for loops. There is the outer for loop and the inner for loop, and this in this outer for loop we have a variable number of rows printed. So we print as many rows as is the height of the rectangle, and then for each row we print as many characters as is the width of the rectangle. So we print this filling character is printed here as many times is the width of the rectangle, and then it is printed on as many lines as is the height of the rectangle. And always when we start a new line, we print the new line character and some spaces. So this method basically it prints the rectangle as specified by these three data members of the class. And you should note also that this automatically it can refer to these data fields just with their names like this. But you should also know that it's when this because this method, for instance, this print rectangle method, it is called, for instance, here it is called. We say that it is called for this the object referenced by this name like this, and then it is called for the other object, and then inside this method we cannot see for which object it is called, but the system takes care automatically that it refers to these three values of that object for which the method was called. So that is automatic. But these values are always inside some object that is specified outside this method. So I think some programmers would say that this is quite a stupid program, or it's not well written program, and that is true. So now we can make it better, I think. And so what is usual in object-oriented programming, that we are using things called constructors. And the constructor is a kind of method that has the same name as the class. So I will modify this comment, and then I will modify the method here. So with the constructors we can build objects or construct objects, and so the name of a constructor is the same as the name of the class. So I will copy the name of the class, and I will overwrite this method name with this name of the class. So now I have a constructor, but the constructor doesn't have a return value, so I have to take this void out of here. But now, after these modifications, it is now a valid constructor for the rectangle objects. And now, when I have this constructor, then I can no longer construct these objects in this way, and I can no longer use this initialize rectangle method. But now I can take these three values that are given to the initialization method. I can take these and give them as parameters for the constructor, like this. I will take these out from here and set them as parameters for the constructor, like this. And now I can take out these two lines from the program. So now the program works as before, or we can test it. I will save it, and I will recompile it, and I will rerun it so it works just like before. So now I have a real constructor in this program or a constructor for which I give some values, and now these values go, so these 3 values now go as parameters for the constructor. So these variables are getting those values, and then we are just copying them to the data fields of the class. So the constructor is usually an initialization method. So actually it is often also possible to have many constructors in a class, so we could now create a default constructor for this class, and a default constructor, it would be something like with this name, but it would get no parameters. So let's make a default constructor then. So I will copy this, or I will take this out, and I will copy now this constructor that we just made, and I will paste it here, and if it is a default constructor, it doesn't take any parameters. So it looks like this, and then in place of this I should write some default values. And well, let's say that the default width of a rectangle, let's say it's 6, and the default height is then 4, and the default filling character is then let's say, I think D is a good character for that. So now I have 2 constructors in this class. So this is now called default constructor, and this is another constructor, and now I can create one more object like this. Let's say it's called default rectangle, and I give it no parameters. And then I print it. Like this. Let's see what happens. I will save it, and I will first compile it, and then I'll run it. Now we can see that it printed this constructor, or this rectangle that is 6 characters wide and 4 lines high, and it contains letters D, just like we specified here. Actually, it would not be necessary to write these values here, so we could equally well write the default values here, like this. So if we do it this way, we don't need any statements here. But we still need to have this constructor specified like this, although it doesn't contain any statements. But it should work also this way. Let's test it. I'll compile it and then I run it, and it works like this as well. So now we have a default constructor and we have another constructor, and with the other constructor we can specify what kind of rectangles we want. And in the original program we didn't have a default constructor there, but we were still able to create the rectangle objects with this kind of statement. So there is a rule in Java object-oriented programming, and the same rule is also in many other languages, that if there is no constructor in a class, then the compiler or the system automatically creates a default constructor that does nothing. But if you have another constructor, or if you have some constructor written into a class, then you need to specify also the default constructor for the class. Well, some programmers might complain about my naming here. So I write default rectangle and then I write print rectangle, second rectangle, print rectangle. So maybe because we have the word, I am always repeating this word rectangle, so maybe the name of this method could be shortened to just to print like this. So I will shorten it. So let's test it one more time. Well, it still works. This is also very important to notice, that when I compile this program, you can see that now there are two .class files when I compile it. So there is a rectangle.class and there is rectangles.class. So this is a general rule in Java that for the compilation produces for each class, it produces a separate .class file, although these two classes are now in the same source program file. So I will not modify this rectangle class further. Let's then study a little bit how the memory is used by these objects, and let's because well, I will take these two statements out of the program for the time being, and so what because I have right here rectangle, first rectangle, and then I create the object, and so actually there are two things happening here. So I could replace this statement with two statements like this. Like this, and so what is happening here? So here I specify a thing called object reference. Oh, I did something. So here I do specify an object reference, or declare. Oh, I will write it object. So here I create an object reference or specify an object reference, and then with this operation I then create the object and I then make this name refer to this new object. So what does this mean in practice? It means, I will also modify the other statement in two parts. So like this. So I have now, and here I create another object reference, and then I create an object and make this name to point to the new object. So what happens in practice is that with these operations, with this kind of statement, I just specify a kind of variable, and we can actually draw this thing. So I have made here a drawing so that we can always think that the main memory of a computer is like this. A long list of bytes where we can store information. So when I write like this first rectangle, when I create this, so we can think that I just reserve some memory, and with this name I can refer to this piece of memory. And this is a kind of variable or memory location where I can store the address of an object. So this means in practice that all objects, they have some, or all variables and all objects in a program, they have some addresses, and then when I create an object like this, so here I create an object, and this means then that because now this class rectangle, it has now 3 data members. So it means in practice that I reserve memory to store the 3 values. So what practically happens there when I create the object, that there in the computer memory I reserve an area, or the system automatically reserves an area, and there it stores these 3 values. So they are the 7 and 4 and the character code of the Z. So, and then in this operation, when the object is created, I make the first rectangle refer to this new object. So this object has now some address. It has some numerical in the real memory. It has some address, and we can think that this address is then stored into this variable. So this is how this first rectangle refers to this object, or we can say that it points to this object. So you can think it this way. Well, in reality, this referencing to an object can be more complicated, as is shown here, but this is the principle, that we have an object in the memory, and then we have a variable or object reference that refers to the object. And then when we have this other statement, we specify this second rectangle object reference, so that works the same way, so that we reserve some memory, and this name second rectangle refers to this variable or object reference, and then when we create the object like this, we again reserve some memory there, and that memory will contain these values, these three values, 12, 3, and the character code of X. And again, then in this assignment statement, the address of this object is then stored into this variable. So you can think that this is how memory is used when objects are in use. And then we can also think that, well, if we modify this program a little bit, I will modify it so that I will, in place of, let's take this out from here altogether, and I will write here so I write here first rectangle, new rectangle. So here we create the default rectangle. Let's first compile this, or save it and compile it. So it still compiles well. But now, well, I have to print this. I created a new rectangle object, but I didn't print it at all, so I have to reprint the first rectangle here, and I will compile it and run it. So now we have a different situation here. So we have, in this, if we continue this drawing operation here, so I now create a new rectangle, which is the default rectangle, and again the system automatically reserves memory space for the three values, and now the three values are the default values, and they are mentioned here. So they are 6 is the width, and 4 is the height, and D is the filling character. So that's the default rectangle, and in this operation now I assign this to the first rectangle. And what happens here is now that this, so there's again here, there's some numerical memory address here, and the address of this rectangle is now copied here. And what happens in practice, and then I also print the first rectangle. So what happens in practice now this variable, it is first pointing to this object here, but then after the second operation we create a new object, or in the end we create a new default object, and then we make this name point to that new object, and for that reason we can see that this last printing operation, it prints the default rectangle. So what happens here is that this object that was originally referred by this first rectangle, it is now in the end of the program, or at the end of the program, it is no longer referred by this first rectangle, and so this object in the memory, it is a kind of garbage, useless object, because nobody is referencing it. So in object-oriented programming or in Java programming, there is usually a mechanism called garbage collection. Garbage collection. There is this mechanism that it collects automatically. The system automatically destroys all the objects that are no longer in use, or objects that are not referenced by anybody in the program. So if this would be a real program and this program would be running long, then it would happen that the garbage collection would delete or destroy this object from the memory because it's no longer referenced. This garbage collection thing is also referred with the term automatic memory management. So yes, so they are basically in object-oriented programming. In Java object-oriented programming, there are two kinds of memory areas in use. So these objects that are like variables or object references, they are stored into memory area called stack memory. Stack memory, and the other area into which the objects are created, that's usually called the heap memory. So these are terms that you will see when you study programming. Well, I think that now we have studied enough the basics of object-oriented programming, and this is a very simple program, and in future lessons you will see more complicated programs. Well, I thank you for your attention, and goodbye.